Hi, in this video we'll be talking about state retention across function calls. Normally, when a function returns a value, the value is all we have. All the other information held in the variables inside the function is lost. But there are multiple scenarios when data must be remembered across function calls. There are a couple of ways this can be done. Let's have a look at what options we have. First, we have global variables. A simple, although not optimal way of retaining state across function calls are global variables. So variables defined directly in the module, outside any function or class. If you want to learn more about global variables, I have a video about them. Feel free to give it a watch. And now let's have a look at the following example. Here, the enclosing function manage_score defines the score variable in global scope and sets it to 0. Global means this should be defined in global scope. It also defines the hit function as a nested function here and returns it without calling it. It just returns the function. The hit function also declares the score variable global, which means it uses the score variable defined in the module. The nested function increments the score variable by 1 and prints the current value of the score. With the function defined, let's use it in interactive mode. Let's assign the hit function returned by the manage_score function to should1. Should1 equals manage_score. Now, should1 is the hit function returned from the manage_score function, so we can call it like a function. And as this is the hit function now, it should increment score by 1 and print the following message. Just hit an enemy. Your score is, here comes the score, points. Enter. Just hit an enemy. Your score is 1 point. Slightly ungrammatical, but doesn't matter here. Now the state is retained in global scope. Let's run the function again. Should1. Enter. Just hit an enemy. Your score is 2 points. As you can see, the state is really retained in global scope. Let's try again. Just hit an enemy. Your score is 3 points. If we keep assigning and calling the hit function, the score will be incremented and printed each time. And now let's create another hit function object. Let's call it should2. Equals manage_score and let's run it. Should2. Just hit an enemy. Your score is 1 point. And let's run it again. Your score is 2 points. Now, if we use global variables to retain state, we can only retain one copy of the state. Let's use the should1 function again. It left off at 3, so now it should be 4. But is it? Let's check it out. Should1. Your score is 3 points. No, it isn't. Both should1 and should2 share the same state of the global variable. If you want independent copies, non-local variables with closures could be a solution. Let's look at them next. So the second option are non-local variables and closures. If we declare a variable non-local in the nested function, the program then works on the variable with that name which it finds in the enclosing function. If the enclosing function returns another function, and if that returned function remembers state from the enclosing scope, we call it closures. I have a video on closures, so if you want to learn more about them, feel free to watch it. Now let's modify our previous code. So we don't need that. And here we need the nonlocal declaration. Nonlocal score. Fine. This now means that we're working inside the nested function on the variable defined in the enclosing function. Fine. With this function changed, modified, let's run it in interactive mode. And again, let's assign the hit function returned by the managedScore function to should1. Should1 equals managedScore. Fine. So now should1 is our hit function. And let's use it. Should1. Your score is 1 point. 1 point should be, right? Now, although the managedScore function in which the score variable was created has already returned its state, which is the value of the score variable, is still remembered by the return hit function. As we can see, the value is incremented and printed. Now, if we keep assigning and calling the hit function, the score will be incremented and printed each time. So let's try it again. Should1. Now we get 2 points. And one more time. Now we have 3 points. And now let's create another hit function object. Should2 equals managedScore. And if we create another hit function object, it will remember its own independent copy of the score variable. So let's call the should2 function. Yeah, just hit an enemy. Your score is 1 point. And if we now call the first hit object again, it will remember where it left off and it will continue. So it left off at 3. And now if we run should1, it'll continue at 4. If you want to learn more about nonlocal variables, I have a video about them. Feel free to give it a watch. I also have a video on scopes, which is related to the topic of nonlocal variables. So give it a watch as well if you want. Another way of retaining state across function calls are function attributes. These are names that we attach to functions. Function attributes use the same dot notation as class or instance attributes. They work pretty much the same as nonlocal variables. One important difference is that they are accessible outside the nested function. Let's modify our previous example again. This time we'll be using function attributes and closures. So first let's get rid of the nonlocal declaration. We don't need this variable here either. Instead, we'll define a function attribute. This is an attribute on the nested function, so it may be only initialized after the nested function is defined. So let's initialize the attribute here. Hit.score equals 0. But we can use this attribute inside the function. Hit.score plus equals 1. And we need to use hit.score, the attribute notation over here. Fine. Let's run this code in interactive mode. And let's again create the should1 and should2 functions and call them a couple of times to confirm that each returned function has its own copy of the attribute. So here we are, should1 equals manage score. Let's call should1. The score is 1 point. Let's call it again. 2 points. Now let's create should2. Manage score. And let's call should2. Your score is 1 point. Let's call should2 a couple of times. 2 points, 3 points, 4 points, okay? And now let's call should1 again. Well, should1 left off at 2, so now it should start at 3, and so it does. Well, function attributes are also accessible outside the nested function. So let's see what values they have for either of the two functions. Should1 dot score, should2 dot score, 3 and 4 respectively. And this is right because score1 finished at 3 and this value is retained, whereas should2 finished at 4, which is here, the current value of the attribute. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.